Okay, we're going to have a look at this question here from the 2016 Breadth paper, this question 21. It's a really nice example of a SUVAT question that I'm going to show you how to work that out on this paper behind it. I'll just zoom it in so you can see that nice and close. So we've got, I'm not going to do the whole question, I'm just going to do the SUVAT aspect here. So we've got a trolley being suspended on a ramp here by a string, and at a certain time, time 0, it's cut, and then what we've got is the trolley rolls down the hill with an acceleration of 3 meters per second. Calculate the time taken by the trolley to travel a distance of 0.8 meters down the ramp. So that's 0.8 meters down the ramp. Okay, so in order to do a SUVAT problem, you need to, first of all, write out your letters, and I'm just going to try and pop that up at the top there. So you can obviously write some of the numbers down you see there. If you need to, you can obviously rewind it and come back to it. I'm just going to put it off the screen for a second. Okay, so we start off with a list of things we know. So S, U, V, A, and T. So what are we given? And what are we trying to find out? Well, we're trying to find out the time taken. So we put a question mark there. We know the acceleration from the question. It tells us it's 3 meters per second. Final velocity, we don't know. We're not given any indication of it. So we'll just leave that blank for the minute. Initial velocity, we got an idea what the initial velocity is. This is where the trick comes in. So just before I cut the string, it's stationary, so its initial velocity will be 0 meters per second. And the displacement, S, is given to us as 0.8 meters. Now, in any SUVAT problem, you will be given 3 pieces of information with a 4th that you need to work out. So you need to decide on which equation you're going to use. So in order to do that, we need our data sheet. And there is our uniform acceleration and motion equations. V equals U plus AT, S equals a half U plus V times T, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. So we derived those before. So we've got 4 equations we need to use. So which one are we going to use? So we've been given S. So that puts out equation number 1. We've been given U. We've been given A. And we need to find out T. So we need to have a look at carefully which one we're going to use. So decide which one you're going to use. I'm going to use S equals UT plus a half AT squared. Now, the reason I'm going to use that, and it's normally the one I go to when I see U as being 0. Mostly because we can eliminate a term, and I'll show you that here in a second. So we're going to use the 3rd equation. S equals UT plus a half AT squared. So we need to look at this equation. Look, U is 0, anything times 0 is 0, so this whole term goes bye-bye. So we end up with S is equal to half AT squared. Then we can put the numbers in because we know A and we want to find out T. So we need to do a little bit of rearrangement here. So how do I get rid of the half? Well, I times both sides by 2, so S times 2 is equal to AT squared. How do I get rid of the A on this side? Well, I need to divide both sides by A, so that will be S times 2 divided by A equals T squared. And then finally, we've got a square value over here, so to get rid of the square value, we square root both sides. So S times 2 divided by A equals T, and that's square rooted. So what we can do now is we can then put the numbers into this equation. So S is 0.8 times by 2 divided by 3, square root, and you should get a nice answer when you pop that all into your calculator of 0.73 seconds.